In Part 1, we assess stormwater basins to determine if they need retrofitting. Now in Part 2, we will discuss construction. Once you have identified basins that need to be retrofitted and before bidding out a project, don't forget to consider: do you have easy access to the basin? Can you get construction equipment and materials easily to the site? What will you do with sediment and vegetation that needs to be removed? Can it stay on site, or does it have to be hauled away? On-site disposal equals money saved unless you have to pay for trucking costs or find property for off-site disposal. As with any project, you get what you inspect, not what you expect. Be on site and often. Check in with the operator and clearly define your expectations. Know the ins and outs and the functionality of the design. In some cases, you may be able to just modify an existing riser. The easiest retrofit is reducing the size of the orifice. This could include completely closing off an unneeded orifice or reducing the orifice size and drilling smaller holes further up the riser.
Here's our concrete outlet riser with an 18-inch outlet orifice for plenty of capacity when this thing is full and the water goes in here. But in lower rain events, what you see in there is a smaller hole, an 8-inch. So we have 18 inches going out for lots of capacity, but a small hole being 8 inches to actually restrict the orifice size and retain some water in the basin. So here I am standing in one of the best stormwater controls that we have, a stormwater basin. We have this massive riser here next to me that controls a lot of water when it really rains hard. And this basin held little to no water before we retrofitted it. We just retrofitted about 2 weeks ago, and we had a massive rain event a couple days ago. And we already have indications that this thing is working. If you look over here, you can see a sediment line. I'm about 6 foot tall. If I was standing down in the bottom of this thing, the water would have been about 6 feet deep within this basin. And then if we do some quick calculations, this basin is approximately 100 feet wide and 100 feet long, and an average depth of water would have been about 3 foot throughout the basin. If we do some quick calculations, this thing in the last heavy rain event, with the water this high, held over 200,000 gallons of water that used to go down the stream, but we held it in here for a short amount of time to retain it so it doesn't go down and cause flooding down below us. Some other indications that this worked really well is if you can see this hole right here, how some debris went through it, so we know the water got at least that high. And also we can see our trash rack down below that held some debris back and is now free of debris after the rainstorm. So this basin has been retrofitted just a few weeks ago and is already holding back hundreds of thousands of gallons more water than it used to.
A flat riser grate should be avoided as it can easily become blocked during severe flooding events and cause a basin to overflow and fail. A trash rack is an important aspect that should not be overlooked when retrofitting a basin. There are several options to choose from, or it can also be custom made.
So this is going to be our new outlet riser for the basin. What you can see here is a relatively small hole. It's 8 inches, and we have to keep this thing from being plugged up by a beach ball or a kid's soccer ball. So what we put on these is a trash rack. Now this trash rack can stop the bigger debris from plugging a hole, but also it's a smaller hole. It's a 4-inch hole. So this will actually plate onto this riser to make the 8-inch hole a 4-inch hole. And we do that just in case we want the hole to be bigger someday for maintenance, or we feel that it's retaining too much water. The municipality can come along and unbolt this, and all of a sudden we have a larger 8-inch hole.
Anti-Seep Collars block the flow of water at the interface of the pipe and the backfill surrounding the conduit. Anti-Seep Collars can be made of concrete, metal, or plastic.
Here we are in another basin, and what I wanted to show off was this pipe that's in my hand. We have a conventional concrete riser and a conventional embankment, but this, before the pipe in here or the outlet barrel, was steel, corrugated, or tin whistle. So it was failing and we wanted to replace it. And given the height of this embankment, we were worried about the pipe that we had put in here may crush. So we went with this type of pipe. It's gray rather than black, but it's still plastic. Instead of polyethylene, it is polypropylene pipe. Much more rigid and can withstand the cover before it will crush. And this is conventional plastic pipe. It's dual-walled, smooth on the inside, still has the bail with the rubber gasket that'll fit together. And this is the plastic pipe the contractors are used to using, so really the only difference is it's gray and polypropylene and more rigid. Another big difference when you're going through an embankment such as this, really the only other option with all the cover would be concrete pipe. This pipe, just like most plastic pipes, come in 20-foot lengths or sticks. The concrete pipe comes in 6 to 8 to 10-foot lengths, meaning more joints. With this pipe, it is less joints, less cause for problems. And finally, this pipe is physically much lighter. A stick of this may be about 300 pounds, and the contractor can still work and maneuver it by hand to fit together. Versus the concrete pipe is about 3,000 pounds, and you can only maneuver that with a piece of equipment. So this plastic pipe is much easier to use and more friendly for the contractor to use, but can still withstand the height of the embankment. But note that it is gray, not black, and it is high performance, HP pipe, made out of polypropylene. Here we have a newly installed concrete riser with the outlet barrel, and you can see where the black plastic pipe goes through the concrete riser. You see grout there. It's very important to put grout between that connection to prevent the water from piping on the outside of the pipe and causing the embankment to fail. So that grout is very important to provide a watertight seal inside the concrete riser. Here we have a very newly completed concrete riser, and what's important to show here is how we removed some sediment from the basin and placed it as the outlet barrel goes through the embankment. It's important to completely cover the outlet barrel and also put the sediment next to the riser to prevent floating, because it's kind of like holding a beach ball underwater. When this thing fills up before it flows over this level, it's very buoyant. So we want to have this outlet barrel completely covered with dirt and also backfill completely right against this concrete riser.
In Part 2, we discussed what to expect during construction. In Part 3, we will look at future maintenance needed, lessons learned, and the importance of partnerships. After the basin has been retrofitted, and during the next rain event, grab your umbrella, put on your rain boots, and go outside and see how the basin is functioning. The once malfunctioning stormwater basin that held minimal amounts of stormwater is now retaining large volumes of water in one location. The longer retention time and the larger volume of stormwater retained is now improving water quality and decreasing flash flooding. Westmoreland Conservation District has retrofitted over 20 basins within the past 3 years, and we continue to work with more municipalities and landowners to retrofit these basins. The big lesson that we learned is it actually works.
So this is a basin that we retrofitted 2 years ago, and we're here to see how well it works. Just by the sediment that we see here, we know it's retaining stormwater. If you see the sediment on these leaves behind me, we know that the water was pulled in here for a certain amount of time, and the muddy water deposited sediment on these leaves. We also see sticks on top of the trash rack. We see a sediment line here, and we actually see some debris up to this height, about 5 foot. So we know that this basin has worked and retained a fair amount of sediment since we retrofitted it. Before we retrofitted it, behind this steel plate is a 2-foot outlet orifice. 2 foot carried way too much water and retained zero sediment or water. Now that we necked it down to about an 8-inch orifice with a trash rack, we can see by the evidence that's here that's retaining water and working. This basin is so newly constructed, we haven't even established vegetation on this bank yet, but it's already holding more water than it has in its 10-year plus existence. We just newly put a concrete riser here, and we had a heavy rain last night, and you can see this. You can see a debris line where I'm standing was actually underwater last night. So this basin is already holding more water, and it's only been newly constructed. I don't know if you can see this debris line, but the water in here was at least 1.5 feet higher than it is today. So it's already holding more water. Here you can see a basin is very newly constructed. We don't even have the top on this concrete riser. but we had a lot of rain last night, so you can see the basin water has come up, and it's important to note there's that trash rack collecting trash already. Now it has some fine debris on it because of the construction that was going on, but you can still see the concept that it actually kept debris from plugging that hole.
We've also learned to, number 1, pick the low-hanging fruit. For your biggest bang for your buck, go for the project that has a willing landowner and easy access for equipment and materials to get to the project site. Number 2, conserve resources. Tackle several basins at one time, from bidding them out together to purchasing materials to retrofit in bulk. This will make your dollar go further. Number 3, communication is key. Discuss expected outcomes between all partners, such as the landowner, contractors, and project manager. This is vital in how a newly retrofitted basin will function during the next rain event and in completing a project that is well done. Number 4, expect questions from surrounding neighbors and be prepared to answer their questions. Anytime you are changing something or construction equipment is on site moving earth, questions get asked, especially when water begins to pond in an area that never held water before. Number 5, maintenance is important. Number 6, also be prepared to handle concerns about mosquitoes and West Nile virus.
So typically in a habitat like this, you don't find any mosquito larvae. Mosquitoes do breed in standing water, but in this type of habitat, there's too many predators. Any larvae that do end up in here get eaten. There's damselfly nymphs, dragonfly nymphs, fish, and then when we came up here earlier, there were some ducks on the basin as well, so they'll dip in and eat the larvae as well. Typically, mosquitoes breed in a more organic water that doesn't have a lot of predators in it. It's been sitting there for a while, and the mosquitoes will come and lay their eggs on the standing water. The areas that we find more concerning are typically just puddles, ruts in the ground. Even unaerated ponds can be a problem if they don't have predators within them.
Newly retrofitted basins can be a volunteer event. You can select native wildflowers, grasses, shrubs, and trees to provide an inviting wildlife habitat that is also aesthetically pleasing. Contact your local conservation district to create partnerships that are vital to putting projects like these on the ground.
Most municipalities don't have the staff that has the technical capabilities that the conservation district has. We're not going to get every basin in Murraysville retrofitted through the conservation district programs. We know that. There's a lot that Murraysville's going to have to do on their own. But now they know how to do it because they saw what was done, they understand the process, and even if they don't do it with their own forces, they can contract it out now because they have a better understanding through the conservation district. So we all need to do what we can to ensure that our source of water is taken care of. And our source of water comes from the sky, and it comes in the form of stormwater. It falls down, we collect it in our reservoirs, we treat it, and that's what everyone uses to drink and to wash and do everything else with. So it's very, very important that we all have a stake in how stormwater's handled. It's a great, great resource, the most important resource we have. And every entity out there should be involved in some way. Yes, watershed groups are great. They have their own little watersheds they're concerned about, making sure the water quality is high in those watersheds, and the projects that go on, meet certain standards. Every municipality has to be part of it. A lot of pollutants come from roads, and municipalities have the roads, so they're very much involved in it. All the state agencies, the conservation districts. I can't think of a group out there that doesn't have an involvement in stormwater.
In review, we've shown you how to evaluate and prioritize if a stormwater detention pond needs to be retrofitted, things to consider before design and construction, what to expect during construction, future maintenance needed, lessons learned, and creating partnerships that will lead to better water quality. In conclusion, I hope that you will consider retrofitting stormwater basins. Financial and other support for this project is provided by the Pennsylvania Association of Conservation Districts, Inc., through a grant from the Pennsylvania Department of Environmental Protection under 319 of the Clean Water Act, administered by the U.S. Environmental Protection Agency.
Wow, that's some big stormwater problems. Good thing we have a basin here to control it. Chelsea, hat or no hat?
It's up to you, Rob.
Chelsea, give me an honest.
Probably not a hat. Might take away from what you're trying to see. People be.
Dork alert is going off?
No, I'm not saying dork alert, no, but the hat kind of takes away from everything else.
You want to hold somebody's hand?
I want to hold your hand. You stand right here. You? I'm going to pull you in. Are you ready? You were more scared than I was.